Welcome everyone. In this walkthrough, we'll look at shapes of molecules and intermolecular forces. This is a year one question that relates to the structure and bonding units. We'll look at dot and cross diagrams, electronegativity and bond angles. I'll also explain how to find out if a molecule is polar or not. There are links in the description to similar quizzes. These are on the flipchem.com website. For this video, black text is the question, red text is additional info, and blue text is the answer. Pause the video at any time and attempt the question yourself. Let's get started. Here's the first part of the question. This question is about intermolecular forces. Give the meaning of the term electronegativity. This is a key definition. Electronegativity is the power of an atom to attract the pair of electrons in a covalent bond. Electronegativity also appears in the topic of periodicity, and you will have to be able to state and explain the trends in electronegativity that are seen in the periodic table. Electronegativity is also related to the concept of polar bonds and polar molecules, which allow us to determine the type of intermolecular forces that are present between molecules. Here's the next part of the question. Explain how permanent dipole-dipole forces arise between hydrogen chloride molecules. Chlorine is more electronegative than hydrogen. The HCl bond is polar. There is an attraction between the slightly positive hydrogen in one molecule and the slightly negative chlorine in a neighbouring molecule. I have also included a labelled diagram. It is a good idea to do this in exams so that your explanation is as clear as possible. And here's the final part of the question. Complete the table by naming the shape of each molecule. Place a tick in the final column if the molecule has a permanent dipole. First, find the number of bonding pairs and lone pairs of electrons. A dot and cross diagram may be necessary, especially when you first start. You need to know the names of the shapes and bond angles that are linked to lone pairs and bond pairs. A molecule will have a permanent dipole if it contains polar bonds and the bond dipoles don't cancel. First, let's look at SiH4. From the dot and cross diagram, we can see that there are 4 bond pairs and 0 lone pairs of electrons. The shape is tetrahedral. Bonding pairs of electrons will repel equally, and the bond angle is 109.5 degrees. Each Si to H bond is polar. There is a difference in electronegativity between the silicon and hydrogen atoms. But the molecule is symmetrical in 3 dimensions. This molecule is not polar. Next, let's look at phosphine, pH3. From the dot and cross diagram, we can see that there are 3 bond pairs and 1 lone pair of electrons. The shape is trigonal pyramidal. There are still 4 regions of electron density as there were in SiH4, but the lone pairs repel more than bonding pairs, so the bond angle is reduced by 2.5 degrees. The bond angle in pH3 is 107 degrees. The pH bonds are polar. The molecule is not symmetrical in 3 dimensions. If we put a positive charge on the right-hand side of the screen, then the lone pair of electrons, shown in yellow, on the slightly negative phosphorus will be attracted to it. This molecule is polar. It has a permanent dipole. Let's look at beryllium chloride next, BeCl2. Beryllium is a small atom and will form stable molecules without 8 electrons in its outer shell. Beryllium is also unusual because although it is a metal, it will form covalent bonds in molecules like BeCl2. There are 2 bond pairs and 0 lone pairs of electrons. The shape is linear. The bond angle is 180 degrees. The beryllium to chlorine bonds are polar. There is a difference in electronegativity between the beryllium and chlorine atoms. The molecule is symmetrical in 3 dimensions. Beryllium chloride molecules are nonpolar. The last molecule is chloromethane, CH3Cl. There are 4 bond pairs and 0 lone pairs around a central carbon atom. The shape is tetrahedral and the bond angle is 109.5 degrees. The bonding pairs of electrons repel equally. There are polar bonds present. Chlorine, shown in yellow, is by far the most electronegative atom in this molecule. If we put a positive charge on the left-hand side of the screen, the slightly negative chlorine side of the molecule will be attracted towards it. Chloromethane is a polar molecule. I've addressed the question by filling the table in. You will get quicker at recognizing the shapes and bond angles of molecules with practice. Thanks for watching. Please like, subscribe and hit the bell for notifications. Post in the comments if you have any questions or suggestions. Take care.